everybody, welcome back. This lesson is for Wednesday, March 25th. If you haven't figured out, I'm doing all the lessons all in one day, so that's why I have to keep looking to see what day this is actually supposed to be going with. I'm not totally losing my mind, but just a little bit. So again, this is going to be March 25th, which is Wednesday, and we're going to cover, we left off yesterday with isotopes, and so we're going to kind of, I introduced them yesterday, and we're going to kind of get into more specifics today. So this is picking up with slide number 31. All right, and again, if you want to just listen and like take it all in right now, that's great. If you want to be filling in the notes right now, that's your decision. If you are just using a digital copy of the notes, that's also your decision. But if you have the paper version or have a way to print it, do that. Or if you haven't already picked it up from the office, called in and made that arrangement, that would also be probably the best way to be doing the notes. Just keep it normal like we always have done them all year. Okay, so isotopes, slide number 31. We mentioned yesterday that the isotopes are atoms of the same element, but they have a different number of neutrons. And so a different isotope has different properties than just the regular. So carbon 14 is going to be slightly different than carbon 12. Again, it's still carbon, it's just a different version of carbon. And it's still carbon because it still has those 6 protons, which identify it like the fingerprint. Okay, so the name of the element is followed by the mass number, just like carbon 12 or carbon 14 that we introduced yesterday. Like uranium-235 and uranium-238, carbon 12, carbon 14. And so the average atomic mass is the average mass number of the isotope. So that's why you'll see those numbers, those mass numbers on the periodic table that are not whole numbers. You'll see them as decimal numbers. And I said, hey, it's fine just to round those because it's taking the average of the atomic mass. Okay, so here's, oops, there was a video, I think, maybe not, nope, it's just right here. All right, so there is a brain pop that goes with the isotopes. Please follow that link in Wednesday's information for the 25th. That link will be there for you. Or if you're doing the present mode of the Google Slides, you should be able to click it directly from there. And if I haven't mentioned it, it's kind of blurring whether it was 8th grade or high school that I mentioned. I have made a class for Brain Pop. So when you go to Brain Pop, if you just click it'll ask you to sign in. You don't need a username or password. You just click in with G Suite for Education. You click that and it takes you, like it lets you right in because it already is picking up your login information. So that should work for you. If it doesn't, let me know, but it should be okay on your end for the G Suite for Education. Okay, so here is hydrogen. There's 3 actual isotopes for hydrogen. They all have 1 proton, which you see here, right? Because that's what makes it hydrogen. If you had anything other than 1 proton, you would have helium or lithium or some other element. But because there's 1 proton, you have hydrogen for sure. And so this is called protium, deuterium, and then tritium. Dew meaning like 2, right? Because it has a mass number of 2. Here the tritium has a mass number of 3 because there's 1 proton and 2 neutrons. So when you add those up, you would get a mass number of 3, okay? So it's all the same element, but it's just how many neutrons do you have? And when you add those, that nucleus up, which is the protons and the neutrons together, that gives you your mass number. Don't forget that isotope video from the Brain Pop either. Okay, so now that we know these little tiles and squares, okay, we know that the information, we have the atomic symbol, we have the atomic mass, we have the mass number, the atomic number and the mass number, those things are on there. They're not just like thrown on there and randomly arranged. They have an orderly arrangement to them, and that's what we're going to focus on today. They're systematic, it's predictable, and that leads us, I believe, yes, this is one of our one of the best songs of the whole year, the periodic table song. You will probably listen to it a whole lot. Most people really, really like it. So I will have this linked. please make sure you listen to it. I will also post, there's a little 5 or 6 year old girl. She sings this for a talent show and it is absolutely amazing. So that version of it's pretty cool and I will post that for you as well. Okay, so here we have Dmitry Mendeleev. He was the first one to start arranging things in the periodic table. It's like we need to have a system. Like it can't just be chaos and have no rhyme or reason to how these elements are put down on this chart. So he organized them by reoccurring properties and mass. And so the modern table is actually arranged just slightly differently, but we kind of he got the ball rolling. We were kind of like, well, we need to have an organized process for this. And so we just kind of tweaked what he started, and now we go by atomic number. And so we call this order periodic law. And so when the elements are arranged in an order of increasing atomic number, there occurs a periodic repetition of physical and chemical properties. Notice, periodic repetition, right? That's exactly why it's called a periodic table, right? It repeats periodically and it arranges those elements in a particular way. So we call that idea periodic law. Really, it's a fancy name for something that's just kind of common sense. All right, so slide 38 gets us to the arrangement. So groups are also known as families. And so vertical columns, so if I put mine up here, vertical columns, we're talking like this, up and down, okay? And so the word vertical column has the word up in it. And these are the elements that are going up and down, okay? So when we look at columns, they are called groups because they go up and down. And a student a couple years ago were like, did you notice that group has the letters U up in it and up is U up? And I was like, dang, no, never thought about that. So it was a great way, a cheat to help remember to keep the groups separate from the periods, because we'll look at the periods in a minute and they're the ones that are going to go actually horizontally. Okay, as you look at groups, they have the same number of electrons in the outer energy level. So if you remember back to Niels Bohr, where he had those different, like a bullseye, like concentric circles, and it had electrons in them, we're going to focus mostly on either the total number of electrons or the number of electrons in that very outer area, which we'll call valence electrons, and we will get to that idea here next week or maybe the end of this week. Okay. But these are organized by the number of electrons in that outer energy level. And each level can have a maximum number of electrons. And this will make more sense as we start looking at some examples. And each row ends when an outer energy level gets filled up. So you'll start with 1, 2, 3, 4, 5, 6, 7, 8, and then it gets full, and then you have to drop down and come back to the next level, keep going across, and then it gets full, and you drop down and come to the next. All right, so that's kind of the setup. And we can use those outer electrons and draw something called electron dot diagrams, or electron, they call it the dot model, to represent the outer energy level of electrons. And we'll get to that more here soon. There's also periods that go horizontally. So these are the horizontal rows. So we had the vertical columns, now we have the horizontal rows. And so think about how you read a sentence. You read from left to right? And then it ends with a period. So you might think of it that way. Or think about like rowing a boat. If you're on a river, you're rowing horizontally. You're not like rowing up or down, right? You're rowing left or right, which is horizontal. And so those are just two different ways to help kind of remember periods. These are arranged by increasing number of protons. So it matches the atomic number. So it goes hydrogen 1, helium 2, and then it drops down, and then it goes to lithium, and it starts going across. And so you're basically counting protons, 1, 2, 3, 4, as you go across. And if you look at your periodic table as I'm talking about this, you can see that. Hydrogen 1, helium 2, lithium 3, beryllium, then boron. And you're going 1, 2, 3, 4, 5, and you just keep counting, okay? We classify these based on what kind of material they make, which is a metal, a non-metal, or something even called metalloids. And those are vocab terms that hopefully you are getting familiar with. So just like we compared the atomic number to the mass number, here we're going to compare groups with periods. Every once in a while you'll hear somebody call them families. Most of our language, it always uses the word group. I just want to put that in there in case you're like, what in the world, what's a family? It's the same as a group. Okay, again, we're a little schizophrenic in science and we have multiple names for the exact same things. So groups are the vertical columns, and if you think of like the pillars or columns in the White House, right, they're up and down, they're vertical, and they're classified by the number of electrons in the outer shell. Periods are horizontal rows. Think of rowing your boat down a river. It moves left to right or right to left. And it's classified by number of protons, so increasing number, 1, 2, 3, 4, 5, and you keep moving left to right, just like you would read a sentence on a page. We have a Mr. Edmonds song. It's a pretty good one. I will have that linked for you, and you can watch that on your own time. But that is going to be where we stop for today. We will get into some more of these details and the arrangement and the predictability of the periodic table tomorrow. So have a fantastic day, and if you have any questions, always let me know. Thanks.